So I just got this paper back and I'm quite upset. I got an F on it. I know I did these problems wrong. Okay, Google, help me out here. I enter this into Google and yes, I get the exact same answer I wrote down. Why is it wrong? What about the 23 feet? 23 feet to meters and yes, this is the exact answer I was given. Why is this wrong? Well, she wrote mind your significant figures. So here's some significant figures. I don't get it. Why are these people important in my math class? Significant figures. All of these had a significant impact on history, and they're all figures. Something's up. What is wrong? Aristotle, you're going to have to help me. All right, let's look at this in a new direction. I measured this room, and it was 23 feet and 5 inches. So if it was 23 feet and 5 inches, I rounded it from the 5 inches to just 23 feet for my homework. There's no way the teacher knew that. But look at this. Well, 2 decimal places is centimeters, and then 3 is millimeters. How did my rounding get so exact? I was 5 inches off, and now I'm not off even as much as a millimeter. All right, I get it. Significant figures. Okay, these are always measures and thus should be accompanied by their units. You can see seconds, miles per hour. Here I have decibels, the measure of sound. We've got years and gigabytes. I really like here liters. And we've got inches and feet and meters and Fahrenheit and Celsius and Kelvin. And you can see on here I've got so many other things, but they always have units. Always units. All right, so what if you're coming along in math class and you run into something with pi? I love pi. It's a beautiful number. And you can go 1 pi and 2 pi and this kind of stuff. It's kind of like a unit. Well, pi is a number. It is not really a unit. So it does not change my significant figures. All right, so any number other than 0 is significant. When I was young, I had a hard time understanding the number 1, and 2 became my swan for me, and then I got the loudmouth 3, the laptop 4, 5 trying to talk to 6, 7 just playing it cool, 8 was the beautiful girl, and 9 was my relaxation. But 0 is the problem when you come to significant digits. We will spend the rest of this video trying to figure out about significant digits on 0. Everything else is important, but 0, he just likes to goof off, and sometimes he's important and sometimes he's just hiding and you never really know with him. All right, so here we go. If a 0 is between 2 numbers, then it is significant. So this 6 and 7 are like holding on to 0 and making sure he's there. So we've got 3 digits here, 3 significant digits. All zeros that are used as placeholders are not significant. So I've got 527 there, and then 527 with 3 zeros. This makes it 527,000. Those zeros are just to push the numbers to the thousands. They are called placeholders. So they are not significant. They're just holding my number in the right place. This can be true in the other direction. 0.00527. Those 2 zeros are simply holding my numbers back to a smaller place. They are again placeholders. Now what is this 0? It's not really holding anything anywhere. I mean, we could write it without. See, I wrote it no problem without. So what is that 0? Well, we'll get to that in just a second. All zeros to the left of an understood decimal point but the right of the last number are not significant. We just talked about this, so the 527, those 3 zeros are not significant. They're placeholders. All zeros to indicate a decimal are also not significant. So we can write the decimal like this, 0527. And oh, did you see that? That sneaky zero just tried to get me. Sneaky zero. Okay, so 0, I can put that 0 in front of that point. And then I have 527. So that is the 0 we're talking about. So if you actually understand this first one, you will be able to understand the others. The first one is the most important. Placeholders are not important. All right. So any zeros to the right of a number but to the left of a decimal point are significant. Right of number, left of decimal point. So we already know those three are not important. But what happens if you have 527 and you have these zeros here and you have a decimal point? This decimal point is very special. It has the ability to lasso those three zeros. So 527, the zeros caught between the 7 and the decimal point are lassoed and caught, and now they are significant. So this one has 1, 2, 3, 4, 5, 6 digits, and the others only had 3. So this decimal point is very important. One more rule. Any zeros to the right of a number and the right of a decimal point are significant. So what if I was trying to measure 25 centimeters? Right there's 25 centimeters, and I'm trying to make sure it's exactly 27, not rounding to 27. So I'm going to make sure it's 27.00. Those zeros are telling me how well I measured. Again, that point is lassoing those zeros. So now I have 4 significant digits.